A certain patron of ours, who will remain nameless, unless they want to be known, they can speak up, has asked about doing the basics. So we're doing something out of here. The Programmer's Reference Guide. Now, this is the later edition. Print. 21st printing. So this is the 21st printing of this. I used this rather than the originals, because the originals are a bit fragile, to say the least. And what we're going to do is we're going to try and control. It's Young who asked. All right then, mate. So what we're going to do is we're going to use this as our reference on how to control a sprite around the screen. Yeah. So, which I know that Brendan's been trying to do. And what I thought we would do is we'd do it in BASIC first, and then move over to Assembler and do it in assembly. So you understand the mechanics around the sprites. So you are, if you're following along, you want page let's see, page 131 in this book, page 131. In fact, I'll put a marker in there so I can get it quickly. I've also got it here. So here's the reference guide. So if we need to, we can use this. Yeah. So 131. It's not quite there. That's 112. Let's go a bit further. Here. So we're going to start here. Alright. So if you've got this book, or you've got the PDF, we're going to be using that. Now, we're not going to be using the examples in that, because you can do that at your own. What I'm going to do is we're going to write a small program that allows us to control a sprite around the screen. So what I'm going to do is I'm going to pinch Monday's sprite that we used on Monday. Hang on, let me find it. It was in there. Or was it? I can't remember where I'd done it. Anyway, we can grab the new. We can grab the ASM file, and if we need to, I can't remember where did we do it. Must have it in here somewhere. Recent projects. Is it that? Aha, there it is. Right, okay. So, where is that? Where is this? Right, okay, so it's there. Aha. Got ya. So what I'm going to do is I'm going to use that in here. There we go. Right, that's copied that in there. So if we go back. to... So this is gonna be... This will be put into my GitHub after tonight. Right, there we go. So we have got sprite, and we have not got a sprite head editor here, and I don't know why. Got the characters and screen editor. Where's the sprite editor? That is very, very strange. Can I import? Hey Stuart, basic programs can't. The sprite editor's not available on basic programs, is it? Is it? Well, why can't I see it? Oh, it's the old one because my version 4's all screwed up because I've got the latest source code, so it's not quite working properly yet. Right. Well, I'm going to do it this way then. We'll use this. We'll grab that and we'll export it as a listing. Right, so let's do this. Start as a listing. Start from label. Oh, I don't want to get, I want to export to a listing. That's better. Basic data, start at 1000, increase, generate 3, blah, 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 go. Right, so we'll grab that. Whoops. We'll cut it out of that to make sure that that's still okay. Go back to ours. Nope. It keeps forgetting where mine is. Right, so GitHub, Twitch streams. Right, so this is our main one, and I've just exported the assembly, haven't I? Ugh. Hang on, can I have two going at the same time? Let's have a look. Right, let's do this properly. File, export, to listing, basic data. That's what I did. Oh, I can't do it now. Alright. Right, that should have put it in. There it has. Yeah. I've said basic data and it's coming back with the assembly data. That's a bit pants. Ugh. Oh, there must be a bug in it. Oh, that's... Oh, I want to export this as data. Let's try something else. Add new file. Right, let's see if it does it this time. Export to listing, basic data, go. Thank you very much. Thank you very much. That's what I want. Copy. Right, so there, the sprites I have copied from the maze game. Yep. And so the sprites are basically that way, that, and that. So we have got our sprite. So I can shut this down now. So we have our sprite data. It happens in 4042. Okay. Right. So ignore that. Now, to get a sprite on the screen, you've got to switch it on. Yeah? Now, because we're using basic to start with, we're gonna name some variables. So sprite on equals, and that's 53269, and that is the byte location to tell when you want the sprite to be visible or not visible, and we'll get into that in a bit. Then we want sprite x, which is equal to 53248. Sprite y equals 53249. So we are talking sprite. Yes, I know, mate. I mean, yeah, if we can do that. Right, so Vic chip equals 53248. So this is going to be 21. This one is going to be VC, and this one is going to be VC plus 1. Right? Thank you, Stuart. Is that how the good book says it? Hang on, let me have a look. Because I ain't looked at the listings in here. Hang on. So it does. So the good book. So that's how the good book says it. Right, okay. We'll do as the good book. Right, so we're only talking about sprite 0, yeah? So rem only using sprite 0. Now, the C64 has 8 sprites, sprite 0 to sprite 7, but we're only going to be using the 1, alright? And we're only going to manipulate that 1 going around the screen. So at the moment, the first thing we're trying to do is we're trying to get a sprite on the screen. So we've done sprite X, sprite Y, then the sprite color. So this is where we tell what the sprite color is. So that's going to be V plus 16, 32, 39. Is it 39? 16. Yeah, 39. Thank you. And that is basically what you need for the basics. So next thing we need to do is we need to define the sprite. We need to define the sprite. Yeah. Now the thing is, sprites are stored in memory in 64-byte chunks. So the VIC chip can only see 16K at any one time, and by default it only sees the first 16K by default. So when you switch it on, the VIC chip is looking at the first 16K of your memory. So we're not going to change that. We're not getting into the more advanced stuff of screen addressing and stuff like that. We're just sticking with what we've got. So sprites are in 64-byte chunks, which means that you can have 256 sprites in 16K. Yeah. Now, to tell the VIC chip which 64-byte chunk we require, that is called a sprite pointer. Yeah, and we have 8 sprite pointers, for 1 for each sprite. So sprite 0's sprite pointer, so we'll call it SP, is equal to 2040. Looking in the good book. Looking in the good book. Sprite pointers, here we go. Yeah, 2040. So that is our sprite pointer for sprite 0, which is the one we're going to be messing around with, yeah? So, we've got the data for 4 sprites here. And we're going to store the data in a specific position. So, to work out the specific position is, right, you say, okay, I want to put it in 12288. I think that's the number. One, 2, 2, 8, 8. Yeah. So we're going to put our characters, our sprite data at 1288. So to work out the sprite pointer, you need to divide that by 64. That should give you 192. Right? So we are going to store the sprite data at sprite location 192, 193, 194 and 195. And so when we come to manipulate, we know that. But what we're going to do is to tell the Vic chip what sprite 0 is meant to be looking at, we can... Why? Oh, my scroller's gone funny. Oh well, I'll sort that out later. It's the screen RAM plus 10. Oh, right. Oh, yeah. Yeah, but we're not... Yeah. But we're talking the basics here, Stuart. So it's 2040, 2041, 2042, 2043, 2044. We'll get into that when we do the advanced stuff in later streams. So... what we're going to do is we're going to read the data that we've got down there and we're going to store it in there. So we're going to go for I equals 0, 2, and we've got 4 sprites times 64. Let's just make sure that's right. 3, 6, 9, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's count this properly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 22 times 3. Oh, that's not right, is it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's better. 21 times 3 is 63. So we need to add another data point. Because we are talking 64. Now, I think we could have padded it out in CPS. But I'm going to pad it out here anyway. That's 1, 2, 3, and 1 at the end. But I think we could have exported it with the pad out, I think, but I didn't. I forgot to do it. So we're gonna load from 0 to 4 times 64. 3 times 64 because 0, 1, 2, 3 is 4. Then we're going to read byte. We're going to read byte. And then we're going to poke it in fact, let's do a thing here. So base equals 12288. Well, no, base. I keep forgetting 2 characters. So poke BS plus I, comma B, and then next. So that's going to read the data and plonk it in the memory. So we're defining. when I read it, when I said it, I thought, oh no. Anyway, so now we've done that. So next thing we're going to do is we need to turn the sprite on. So we've got sprite on. Now the way you turn the sprite on is the byte has 1, 2, 3, 4, 5, 6, 7, 8 bits. Yeah, and sprite 0 is that bit there. Is that bit. So it's all bit manipulation for turning a sprite on. The other ones, that one's for sprite. So that one's for sprite 1, sprite 2, 3, 4, 5, 6, 7. But we're only interested in sprite 0. Now to turn that on, what we have to do a poke into SO, comma, then we need to read what's already there, SO, and then OR it with 1, and that turns bit 1 on. And what we're doing here is we're peeking what's there already, we're ORing it with 1, and then poking it back in so it stores it back. That turns the sprite on. Next, well, in fact, let's run it. Let's see if it runs. All right. Yeah, I'll hold. Hold for caller. Yeah. So, on line 110, yeah? What is red for? Right. The poke command puts a value into an address, yes? So, what happens here is this value here, it needs to do the peek first. It needs to do the peek first to get the value. Then we OR it with 1. Yeah. And then that value from there gets poked into SO. Yeah? So in terms of how it's executed, the poke executes the value first to evaluate the value, and then whatever that is, it puts into the address. Right? So we're going to run it now and see if, let's see if it works. Right, let me save this. So here we go. So we're going to run it and see if it works. And of course, it's not going to work because it's running a pet emulator. Hang on. Let me just change that to C64. Oh, it's targeting a pet. Oh, that's nonsense. And I can't change it either. Stuart, wait. Don't panic. I know what I'm doing. But first, I've got to get it back into a C64 mode. I'm going to get this project back into C64 mode. Right, let me see. I've got to see if I can get this back into C64 mode. Because it's in pet mode at the moment, because that's what I was using it for last. Hang on. Don't do this at home, folks. Target is 3. Right. Target is 2. Let's do that. Right, let's load that back in. Here we go. We're on the C64. Yeah! John knows his stuff. Oh, and the sprite editor's appeared. Right. Okay, let's put the sprite in there. Sprite data, add existing, 3D sprite. There we go. Nice. That's why it wasn't there. Right. Yeah, pets don't have sprites, yeah. Right, let's run it. F5. Ah! What's gone wrong there, I wonder? No, it's not worked because it's still in pet mode. Hang on. Let me trash this project. Let me trash the project. Right, file. New basic project. See, it's doing pet. It's targeting a pet. New project. C64 next. Right, I am putting it in there. And it's called 10 sprites. Next. Okay, there's a directory there with that name. Yes, I know. Right, now do it. Right, add new file, main. And I'm going to put that into there. That into there. Zap that. Right. Sprite data, add existing. Right, we are back to square. So copy that. Paste it in there. Right. See, the professionals have problems. Right, out of data. So we have not enough data. And that's because I haven't got the data already. So we'll do this properly now. So we'll go into here. File, export to listing, basic data from 1000. Generating 3s. Where's the padding? There we go. Pad to 64 bytes. Go. There we go. Right, that sorted that out. Right, F5. There you go. One sprite on the screen. Can't you see it? Can't you see it? It's there. Right. the reason it's not there is because if you go to the good book, right, if you go to the good book, you'll see on page, what is it, 140? 140, you'll see there's a visible area. Yeah, and let me use. Yeah, it's at 0, 0. So if I load my infamous paint program, there we go, and grab me tablet, here we go. So what's happening is, here's your screen. Right, and then we've got this going on the screen. They are straighter lines than I can draw. So this is the visible area. And this is the border. But what's happened is the sprite is here. In this bit here, because the visible area is from, what does the good book say? The visible area starts at 24 there and starts at 50 there, and it goes down to this point here, which is, so that is what, 250, and this one is 320? No, 344. So our sprite is there. So we need to tell it. We need to move it so we can see it here. All right. So we've got to tell it how. We've got to tell it where to move the sprite. So going back to the basic program. So we'll do that. All right. So here we're now going to tell the sprite where to go. So we're going to poke. Whoops, we need my caps lock on. Poke, and we've called it SX. So the X value of sprite 0 with 60. Let's say 60, and we'll poke the Y value of sprite 0 with 60 also. So that's now moving the sprite, which is at 0, 0. So if we press F5 on that now, there you go, one sprite, yay! But the problem is, the sprite is not looking at the data we've just loaded because we haven't set the pointer. Right? So we've moved it, so now we need to poke the pointer, which is, we've called it SP, pointer, and with the number that we've worked out here, which is 192. So that's now telling the Vic chip to look at that 64 block of memory and show that on the screen. So if I press F5, hey presto, we have a Star Trek logo. And that's the basics. Alright. We can change the colour of that because by default it's white. And we've got the variable for the colour. So we could poke, what is it, SC for colour. And we could make it 7. Let's see what that comes out. And it's yellow. Get in there. Pick the right number. So that is the basics of getting a sprite on the screen. That's what you need to do to get the sprite on the screen. Now we're going into the realms of wanting to move the sprite. So what we're going to do is we'll use the keyboard first. And then we'll tweak it to use the joystick as well. So we'll use the keyboard first, and then we'll... Alright, Mikroman, see you in a bit. So, now in BASIC, it's dead easy to use the keyboard. Absolutely easy peasy. It's called get $. Then you say, if $1 equals nothing, then 160. So that's saying, get a key, put it in $1. If it's equal to nothing, get another key. Now, we can start messing around. But what we need to do is, I'm going to change that to 70 and change that to 80. What we need to do is we need to start now saying x equals 60, because that's where we started it. Colon y equals 60. So we need to know where our sprite is. Yeah. So we fixed it there to get it on the screen, but now we need to know where it is. So what we're going to do is we're going to now test for the keys. So I'm going to go with the typical keyboard set of a Commodore 64, which is saying if $1 equals A, then Y equals Y minus 1. If $1 equals Z, then Y equals Y plus 1. If $1 equals that, less comma, then X equals X minus 1. And if $1 equals full stop, then X equals X plus 1. Go to 170. There you go. No, assembly's slightly different, mate. This is why I'm doing it in BASIC first, to get the techniques. To get the technique of getting a sprite on the screen and moving it about, and then we'll convert it to assembly, which is a bit more tricky because there's no such thing as $1. There's no such thing as get and stuff like that, alright? Now, the problem is here, this is not going to work. Right, this is not going to work because what we've done is we're getting the character, we're getting the keyboard press, we're testing it, and then we're altering X and Y. But we're not actually telling the C64 where the new location is. So what we need to do is we need to tell the C64 where the new location is. So, line 220, 230, poke SX with X, poke SY with Y. Right? Then that, whoops, that needs to be 230. That should now move our sprite around the screen. But what I'm going to do is I'm going to add another thing here called C equals 7. And what I'm going to do is go poke SC, comma C. And then here we're going to do if $1 equals, and let's say C, then C equals C plus 1. Nice! And you'll see what I've done there in a minute. So let's run it. F5. Wait a bit. There's our sprite on the screen. So we said Z is to go down. There you go. Gone down. But it don't go down anymore. Don't go down anymore. Why is it not going down? So, hang on. It goes down once, but doesn't go down anymore. Let's see what the problem is. Right, I'm just out of curiosity, I'm going to do print $, because I want to see what's going on there. Right, F5. So it's going to go scrolling off the screen. There we go. Z. Oh, right. It's not coming as Z. It's coming as the... Right, okay. So, because I've got cap lock on, so A, Z, that. Right. Oh, yeah. Well spotted. Well spotted, mate. But it also, the character was the graphic. Yeah? So, we'll put the... We'll put it back into caps, because I'm going to have it in caps anyway. Right, F5. Well spotted, mate. Because it was going down one, wasn't it? Right. So, Z. Now it's doing it, so I can get rid of that print. Okay. F5. Loads of... Yeah, that's why it was only moving 1 pixel. Right. Z goes down. But you have to keep hitting the button to make it do it. Same with A. Same with full stop. Now that can't happen. You'd be destroying your keyboard. So, what we're going to do is we're going to change the way this works. Yeah? So we're going to go, okay. Rem. What's a rem statement in BASIC? I can't remember. Is it that? No. Is it that? No. That? Aha! That. Right. So what we're going to do is we're going to do the same thing again. But this time we are going to say K. Yeah, keyboard equals peak. Open bracket 197. Then we're going to do print K, and then if K equals 64, then 170. Alright, so now the difference between get doing a get and doing the peak. Not sure that actually works in Commodore Basic, mate. I think that just sets X to be -1. And anyway, so the difference between a get and the peak is a get will get 1 key press. So you press it once, that's it. You only read it once. With the peak, it'll always read that the key's pressed. So, and that's why I've just put the print in, because watch. Right? So if I press A is 10. Right, let's write that down. So A equals 10. Z is equal to 12. Right? Comma 47. And full stop is 44. And C is 20. Right. So, we will change these. So we're saying K equals, in fact, let's do that. Do that. Grab that. Paste that in there. Get rid of it. And then we'll change these. Right. So K for A. K is equal to 10. Z. K is equal to 12. K is equal to 47. K is equal to 44. And K is equal to A phase 20. So we've changed the way we're reading the keyboard from a static get one key press and one key press only, so you have to keep banging the keyboard to make it go down, to now reading the actual keyboard scan code out of the C64's memory, which is Pete 197. So if we press F5, we should now be able to move that thing. Oh, and we've still got the print in, so we'll get rid of the print. Right, so F5. So it reads it, puts the sprite on the screen. So now I should be able to press Z once and it goes down until I let go. So here we go. Let go. Press A. Let go. Press full stop. Let go. And press comma. Let go. Now, the other one, which was C. So here we go. Press C. Changes the colour. Or you can keep your finger on it and it flashes. So, do you understand what we've done so far? Any questions on how we've done this? Yeah. Go on then. Go on. Go on, Stuart. What's the question? You ain't been ringing me, have you? Alright, Brendan. That's what I need to... What happens if you move the sprite to the right-hand side of the screen? Well, let's find out, shall we? Now I don't have to keep banging the keyboard to make it do it. Here we go. Oops. It went boom. And the reason for that is because the X value of a sprite is bigger than 256 or 255. So we have to do a little bit of jiggery pokery. So the sprite stops here, which is it's at 255. And I bet you if we print X, if we print X, it'll be 256. There you go. And you can't have 256 value in a byte. So we've got a legal quantity error. So to make it continue, we've got to do a little bit of jiggery pokery here, right? So the way to do it is and it with 255. Think. Whoa, wrong one. I'm used to doing kick. Right, so now, if my understanding's right, it should illegal quantity. Nope, it's now wrapping. There you go. So what we've done is we've taken the value and we've masked off any number bigger than 255. My horizontal scrolling is not working today. Yes, mate. It's not. So now, if you want it to get to the far right, which is what Stuart's saying, then we've got to basically test the x value. Yeah. So basically, if x is greater than 255, then in fact, let's do it on a separate line here. If x is greater than 255, then we poke. Now, I don't think we've got this as a value anywhere. No, we haven't. So let's create a new one. So this is going to be sprite M, for a better word, and that is going to be v plus 16, I think. Sixteen. You know, I don't think you're right there, mate. Let's look in the good book. In fact, we've got the good book up here, haven't we? 16. DO10, not DO11. Right, so we've created a new variable called SM, and what we need to do is we need to poke SM, comma 1. Right, but if x is less than 256, oh, hang on, greater than 255, less than 256, yeah, then poke SM, comma 0. You're just looking at the raster. You got the raster on the brain. So this, and what SM's doing is like switching on a sprite. It's exactly the same mechanic. So in fact, let's do it exactly the same. So we'll copy that and we'll poke that there. So peak SM or it, and this one is peak SM and the 254. So that turns it off but leaves the rest of it switched on. So now if we run this F5, we should be able to go off the edge of the screen. Do 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 do. Do 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 do. Go on. Keep going. Keep going. Keep going. Keep going. If I've done my thing right, keep going. Keep going. Keep going. Keep you going. And we're there. Now if I go backwards, it should cross that boundary without a problem. And there we go. And that's how you control a sprite on the screen. Change the increment to 5. Yep. So what we'll do then is we'll create another one called I equals 5. And we'll change this to I. Alright? So F6. Oh, F6. It's not F6, it's F5. F5. Ready? Go. Hang on. What happened there? Did I put a stupid number in? I equals 5. That. Oh, hang on. Hang on. We'll call it I. We're using I already. Right. That was adding 6. That was adding here 3 times 64 to it. No wonder it was going all over the place. Right, here we go. Go. There we go. In steps of 5. And we go down in steps of 5. There we go. And up in steps of 5. What does the colon do before? Oh, this is just a statement separator in BASIC. Like we've got one here. Look, it's a statement separator. So it separates. So this is a basic instruction, and that's a basic instruction. The colon is just a basic instruction separator. It allows you to put more than one basic instruction on a line. Alright? So we have now got it to basically work on a keyboard. So what we're going to do is going to add a new file. This time we're going to call it keyboard. And I need to take my caps lock off. Keyboard. And we're going to copy everything that's in there into keyboard. So this is the keyboard file. Well, I is set, but the problem is we set it here and then we overrode it. That's why I changed it to I. So we're using a different variable name. All right, and that's why it was skipping, because I was 3 times 64, so it is a big jump. Right, so that's the keyboard way. Now you said you wanted to be able to work. You wanted to be able to control it by the joystick, yeah? Hey Winston. Right, the reason I chose that is because the way BASIC works. Hang on, let me go back to the trusted tablet. Where are we? So let me do file new. So this is the memory map of the C64, yeah? So, yeah, so this is 0 and this is, well, 65535, yeah? So that's the complete memory map. Now, the VIC only sees, as I've said before, 16K. So currently the VIC sees this only. Now, the problem is the Commodore 64 in BASIC uses that amount of space, and that's for screen and storage. Right? And then we have our basic program. So our basic program is there. Basic. And then what happens is, the way BASIC stores its variables, it stores all the, so this there, that stores all the number variables, but it also stores the string variables at the top there. Well, not there. So let's see, that's 32. So end of basic is roughly here. So that's end of basic is roughly there. But it stores the string variables from the top. Stores it from the top of basic. So what I've done is I've taken this 16K block, because that's what we're talking about. So let's draw another picture. So here's the, so this is the 16K block. So we've got screen, storage, basic, prog, vars. And so here, way out the way, is 1, 2, 2, 8, 8. And we've taken that slice to do the sprites. So it's out the way of basic, and it's out the way of the basic, and it's also out of the way of the basic variables. If we put our sprites, say, whoops, if we put our sprites there, the sprites would get overwritten by the variables that basic creates, and then we'd end up with garbage sprites. So what you do, you put them way out the way. Now, even in the good book, I think it uses 1288. Hang on. Let's have a look. Where does it say? Where does it normally say? Let's find a listing. Here we go. Where does he do 192 here? Yes, it does. Right. So what page? 146. So in the good book, page 146 is where we're looking at here. So let me make that fit the width. Look. So it's poking 2040192. So that's where it's putting the sprite data. So if the good book says so, that's where we're putting it. But yeah, you have to think how your basic program's going to work. If you've got a lot of string variables going on, then you've got to be careful, because string variable data is from the top down, as numeric data is from the bottom up. Right? And that's why normally people pick 192. No, the oh, there, yeah. Oh, that's poking us. That's putting a sprite in the cassette buffer. Yeah, that's poking the sprite in the cassette buffer. Because the cassette buffers, cassette buffer's 120 somewhat characters, I think. So yeah, so because it's poking the sprite into the cassette buffer, it means it's putting 13 into the sprite pointer. So 13, remember 13 is the pointer. So you times 13 by 64 gives you the memory address. So in our case, we did it reverse. We decided we're going to put the sprite at that memory address. So we divide by 64 to give us our sprite pointer value, which is 192. Alright, so Brendan, does that make sense? Have you got any questions before we try and make this work off the joystick? You alright? Oh, okay. Yeah? Because the joystick is a bit more... fiddly. Right, so that's the keyboard way of moving the sprite around the screen. So the joystick is a different animal altogether. So if I try and find where the joystick is in the good book, I'm sure Stuart's there already. He knows this book inside out. Right, so it's around here somewhere. 343. What are we on? 328. Here we go. Input output guide. Here we go. So the joystick is part of the input output, or the CIA chip. And you don't need to understand. You don't need to understand the internal mechanics of the CIA chip, because even I don't understand that. But you need to understand how the CIA chip works. So forget about talking to the printer, forget about talking to a modem. You know, we are looking for page 343, which is the joystick. 42, here we go, game ports. So what the 64 allows you to have, it allows you to have two joysticks plugged in. And they are plugged into two CIA chips. And one CIA chip, I think, runs the keyboard. And the other one does everything else. So, and you'll find that if you use joystick 1 is using the same port as the keyboard. So you can actually get interference. And that's why on most C64 computer games, they use joystick port 2, because that doesn't get interfered by anything. So what we're going to do is we're going to do the same thing. We're going to use joystick port 2. Now, port 2, what's the value of port 2? Is that the number I've got? 56320. Yes, that it is. 56320. So, now, you have to understand how the CIA chip works to understand how the CIA chip works. Right? So we'll go back to here. We'll make another screen. And so, what the CIA chip is going to expose a byte. So that is that's a data port. Yeah, and it has 8 bits, which of course is 1 byte. And what you find out if you look at the good book, it tells you what the joystick values are. So it says that going up is switch 0. Now they call it a switch. We call it a bit. So what we're saying is this bit here is up. Right, let's go to the next one. So bit 1 is down. So this is down. What else are we doing? Bit 2 is left. So this is left. And so this is right. And then fire is switch 4. Or in our case, bit 4. So this is fire here. Right? So when we read that register, that's how it is. But the CIA chip, right? The CIA chip, when... So we've got two states. We've got off. And we've got on. So this is off. And this is on. So when you press the joystick button, it's in the on state. When you let go of the joystick, it switches it off. You know, it's like lifting your finger off a switch. But the problem is the CIA, when it's in off mode, has a value of 1. When it's in on mode, it has a value of 0. So you've got to remember that it's the wrong way round. And that confuses quite a lot of people. It's the wrong way round. When it's off, it's 1. When it's on, it's 0. Alright? So what people tend to do is they take note of this value, yeah, and we mask off this bit because we don't want to know that bit. You know, we're not interested in that bit. So let me... We're not interested in that bit. Oh, do red. Oh, it's not doing red. Do red. Oh, stuff it. Use the keyboard. We're not interested in that bit. We're not interested in that bit. And we're not interested in that bit. So when we are looking at this byte, we're going to have to do an AND on it. And we're going to AND it with this value here. So work this value out. So it's in binary. So this is 1, 2, 4, 8, and 16. So what's that? The total value. Yeah. Now the more experienced will already know what the value is. I'm just asking. 5 points are up for grabs. You can tell me what the value is. And not an experienced one tells me either. Oh, the answer to everything's 42. Right, okay. Right, if you don't know the answer is 31. Right? So what we're going to do is we're going to mask off this because we don't want to look at it. So whatever's in there we don't want to know. We just mask off this bit here. Alright? And then once you've done that, that's the value you've got. Now the way to do it is that we peak. So we take the value. Is peak 56320. Yeah. But then what we need to do is we need to invert it. We need to make the zeros, ones a 0 and the zeros a 1. Now, if my maths is right, we should be able to. Hang on, do they minus? Do they minus? Let's have a look. Yeah, they minus. Right. Yeah, they minus. So what we need to do is we need to peak this and it with 31, and then V equals V minus 31. And that will give us then the values here. This will give us the corrected values to say if it's off it's a 0 and if it's on it's a 1. Alright? It's a bit of jiggery pokery, but this is the better way of trying to understand how to use it. Have I explained it good enough? Because joysticks do tend to be a bit fudgy. Do you understand what we need to do there? Right. So, let's code it. So with this in mind, let's code it. So let's get back into here. So this is our... So we've stored away the keyboard one, so you can use that on the keyboard. So this time we're now using the joystick. Yes. Alright. So we're going to change this. So we're going to say that we'll use J for joystick. So J equals peak 56320 and it with 31. Oh, I better put my caps lock back. And 31. Alright. And so then it's 31 minus our value. So if J is equal to 0, then go back. Because that means nothing's been pressed. Yeah? Understand? Remember, if nothing's been pressed, all of them will be 1s. So all of them being 1s is 31. Then you do 31 minus 31 becomes 0. It means nothing's been pressed. Right, we'll get rid of this line because we don't need it. And we'll get rid of these lines because we don't need it. Now, to test what key's been pressed, you say if J and, so this is going up. So up, if we look in the good book, up is bit 0, right? So bit 0 is 1, yeah? So if we go back to our picture, bit 0 is 1. So you say if J and 1 equals 1, that means that button on the joystick's been pressed. That bit that we're testing that's related to the button is on. So if we go back, bit 2 is down, I think, yeah. So bit 2, so this is down, so J and 2, bit 2 in decimal is 2, equal to 2, then do down. And so left, I think left is the next one, isn't it? Yeah, bit 4. So bit 4, 1, 2. No, not bit 4. It's 4, isn't it? Yeah. So J and 4 equals 4. That does left. That's left. We're doing right here. Hang on. So that's going to be 8. Equals 8. And then the left is J and 4 equals 4. And what we'll do is we'll make the fire button change the colour. So J and 16 equals 16 to do the fire button. So in essence that should work. Has anybody got any? Does anybody see any problems with that? No? Right, let's run it. So wait for our sprite to load up. Right, so joystick. Right, I'm on joystick 2, which is these. So go down. Oh dear. Oh dear. Going down is changing the colours. Fire is changing the colours. They're all changing the colours. Oh dear. What's going wrong? Right. So let's print out J. Let's find out what's going on. Right, down is 2. Up is 1. That's right. 4, 8, 16. That's right. So, why is that not working? I wonder if it needs brackets round it. That's going up. No? Okay, so how did they do it? Okay. I was trying to be clever, but we'll do this. Maybe basics and is not the same as a Boolean and. Right, that should work. Right, there we go, going up. So let's get rid of the print. F5, here we go. Aren't you checking if the bit is on instead of off? Yeah, we've done the inversion though, mate. We did the inversion. So, I'd already explained that the CIA, when it's switched off, is a 1, and when it's switched on, it's a 0. And here, this is how we do the inversion to make it right. So if I'm going down, here we go, going down, going left and right the wrong way round. Left and right are the wrong way round. Oh dear. 4, 8. Right, down, up, right, left, change colour. And that is how you control a sprite from the joystick. Now, the beauty of the joystick is you can go in diagonals. And this is what I was trying to do. So we need to work it out. But hang on, let's put the print back in. Let's put the print back in. So print J. Because I'm sure we can do diagonals. So I'm going to press. So we're looking at the value, yeah? So I'm pressing down and I'm pressing right. Yes. There we go. Right. Okay. So I'm sure it's J and 1. Let's just try it. Let's just try it. Right. Right. So J equals 1. print j and 2 is 0. Print j and 1 is 1. Right. Okay. So that seems to like it. So if I make j equals 3 and then do print and then do it again, that's right, and this should be a 1. Oh, no, that's right. So why didn't it work? Right, so we're going to put it here. So j and 1. Right, we'll see if that does it. Right, F5. So up. So we'll go right, we're going right and up. All right, okay. It did the up. So that's the up, but it stopped doing the right. F5. Let's put the prints on so we can see what we're doing. So we're going down. I'm just going to make it go down. Right, down. So up is the one we're testing. So we're going to go left and then up. So why is it not? It's not doing the up. Right, it's not doing the others because they're not ands. So let's put the ands back in now. J and 2. J and 4. J and 8. And of course fire J and 16. Right, F5. So we're going down, going across. So link right. So now I'm going to go up. There we go. There we go. Down. Diagonally down. Up. So there you go. And so now we've got the sprites going in the diagonals, as well as up, down, left and right. Easy peasy. So do you now you understand the mechanics in BASIC, right? You understand the mechanics in BASIC. So you can apply the same mechanics to assembly. Oh, you learn. Oh, yeah. It's a bit different in BASIC than the machine code version. So we're now going to take what we've learnt in BASIC and we're going to apply it to assembly. Yeah. So let's see if we can get an assembly file up and running. Right. So should we do the keyboard version first? So keyboard key ASM sprite. Right. So we'll tell it to generate a basic loader. No. That's the one. And we're going to start it at 0820. Right then. So I've forgotten how to do things. I've been using Kick so much long. I've forgotten how to do things. Right. Okay. So it's V. Do I have to do label or anything like that? No, I don't. Do I? It's just V. Right. Vic equals 53248. Or to do it properly, D1000. Oh, you using it on proper hard? You're doing it on proper hardware, yeah? So you haven't. Well, you can still use the keyboard. You can still use the joystick in the Vice. Right? You can still emulate the joystick in Vice, like I'm doing. I'm emulating the joystick in Vice. Right? So, you know. Oh, right. To version what, the beta? To the beta. Right. So, we're gonna create some labels. So, sprite on is equal to Vic plus Alright, so sprite on is that. So sprite 0 x equals Vic. Sprite 0 y equals Vic plus 01. Sprite MSB equals Vic plus 10. Color sprite 0 color equals Vic plus 27. The most significant is DO. The most significant bit is DO10. DO10. Do I have to go back to the back to the Bible? DO10. Where is it? Oh dear, I've forgotten what page it was on. That's collisions. Oh, we're getting close. Getting close. There's the areas. Ah, here we go. Yeah, most significant bit. DO10. Right, so DO10 and then the colour is 27. Right, so they're the things.
Hello,
so,
John here. Thank you for following. Hope you enjoy the stream.
Hey, Mickey Mass, welcome. Oh, caps lock on everything. There you go. New follow. Thank you for following. Right. So now, because we're doing the keyboard, so we're gonna enter the keyboard. So, put back keyboard equals 197, or if my memory serves me correctly, C5. Yeah, let's just check. Oh, my memory is right. So we need to start. We need to set up some places. So right. So we need to set up X, Y, X low, X high, Y. They're the things that we said we was using, yeah? Oh, an increment. So we'll do increment equals 5. Oh, we'll do that then. So we need to, so we need some locations. So I would say, let's say, where are we going? There is some memory in the C64 that's never ever used, and it's a reliable place to put said memory. And that memory is O2A7 to O2FF, is not used. So O2A7, O2A8, O2A9. So O2A7, so $O2A7 to $O2FF is not used by the C64 ever. So it's a reliable 80 odd bytes in there, I think. Oh no, not 80. Oh no, it could be 80. I think it's 88 bytes. I think it's 88 bytes. I think. Where's my memory map? Aha! Right, here we go. So page 318. It says unused. So if we go to the good book and go 318, which I know is not going to be there, but so let's. Is that next page? Yeah, 319. Here we go. There, unused. That memory is unused. You can use it to do whatever you want because the C64 doesn't use it. So we'll put it there. So we've got X low and X high. And so what we need to do oh, 88 bytes. Yeah, there's 88 bytes of valuable C64 memory that they never use. So it's a good place to put your variables if you're doing assembly. Right, so what did we do in the basic? So if we fire up the basic file, so we've set all this lot up. Right, so we need to import the sprite data. Right, so we can do, and you've got to. I'm gonna have to cheat because it's been a while since I've been in CPS. Let me just look at Neptune Lander. good old Neptune lander never lets me down. Right, how did we import the sprites? Like that. Right, okay. So we're saying that the sprites are going to go at 3000, which is 12288 in decimal. So our sprites are at 3D maze. Woo! So true, so true. Right, so we want sprites 1 to 3. 0 to 3. They're the 3 sprites. Right. So I'm just going to build this. I want to see if it's doing it. We have an error, I think. Okay, so it doesn't look like 0. Okay. So it's going to be 1 to 4 then. F5. That's better. Right, so we should have a load. There we go. So we've got a load of byte memory that's come in. So that's, we've just imported our sprite data, yeah? I don't think it matters where you put it, mate, to be honest. Because the assembler would put it whichever, but I normally try and keep my assets in the order that I've got them in. So we've got the sprite data in. So if we look back at the keyboard, what do we do? So we've done this for I, so that's what we've done. So now we need to turn on the sprite. So we're going to turn on the sprite. So you can be cheeky, FaZe. But I am not. We're not. Right. This is a beginner's guide to sprites. So we've done it in BASIC, and now we're doing it in assembly. We're not going to be teaching how to read the CIA chip for the keyboard. Yeah, not in this one. We will be doing it for Hunchback. Yeah, we'll be doing it for Hunchback because the keyboard we turned off in Hunchback. But we will be doing it. But I'm not going to be doing it in this. This is just a beginner's guide to get a sprite on the screen and move it around. And now we're doing the assembly way. Yeah? Is that alright? Right. So, we need to turn the sprite on. So, we need to load... yes. We need to load sprite on. We OR it with #1, and then we store it back into sprite on straight away. So that's done that line there. Now we're going to set the initial coordinates, but I'm going to do it slightly different here because I'm going to do LDA #0, store it in X high. LDA #60, store it in X low, store it in Y. Okay. What happens if I said no? Oh dear. Right, so we're initializing the X and Y. So, I know it won't assemble. I've forgotten, mate. You're right. You're right. So, we have now got our X and Y. So we're going to load X low. And we're going to store it in sprite sprite 0x and load y. Store it in sprite 0y. You need points. I know, mate. No one else spotted it. So there you go, mate. There's another 5 for you. Right. So we have now done this bit here. Now we need to tell VicChip that what part of memory to display. Now we haven't put that down here. So sprite 0 pointer equals 2040 or $07F8. Right, so we load hash 192. I'll just put it because it relates back to the basic, and store it in sprite pointer. Sprite 0 pointer. So that is now, oh, I've got a thingy going on here. That is now doing that. And then we set the color. Yeah. So we'll do that as well. So LDA hash 7. Store it in sprite color. Right. So that has now done all of that. So we should technically we should get a sprite on the screen. So if I do an RTS there, we should then be able to build that, and we should get a sprite on the screen. And yes, we do. Yes, we do. There we go. And the crowd goes wild. Where's the data? Really? Really? You're asking me that now? Look, the data's there. Look, I've got it. It's there. You didn't see it. Right, the data is here, mate. It's in the ink bin. We're including the 3D maze sprite set into the system. Right? Yeah. So, one thing I didn't do on the basic one. Oh, I didn't do it on the base. Oh, I forgot. We didn't do this on the basic one. Right, let me do that now. Right, so what we got? That's going up, down, left, right. 4 is left, 3 is right. Okay, let's do that. Did I give it a value? Yeah, SP. Right, poke SP, comma. Now up is default 192. Down, poke SP, comma 193. That is going that way. So that's 195. And this is four. Yeah, that's why I'm only doing the keyboard one, mate. Not doing the joystick one. So when we run that... Oh, I've pressed F6. Sorry, mate. Told you I'd fixed it. There we go. The sprite is now pointing in the direction... Oh! Really? 2, 3, 4, 5. That's going minus. That's that one. Are we not loading that in? 192, 193, 194, 195. We're not loading it in. Hang on. Oh, the kaboom. We must be loading it in. One 192, 193, 194, 195. Why is that not showing? Is it byte 0, byte 0, byte 0, byte 0? Let's try that. I'm not, we'll see. We'll see. You could be right. And you are. Well spotted. Well spotted. Well spotted, you two. So now, if we go, we're going that way, going that way, going that way, going that way. There we go. Right, that is what we're going to try and do in assembly. So we've got the sprite on the screen. We've got the sprite on the screen. It's there. It's ready to go. So next thing. We need to read the keyboard. So, hey Twitch. Hey Grey Defender. Right. So now we need to acquire the keyboard. So what we're going to do is we load the keyboard there, but we'll store it here. So K. I can't use, so we'll use the same word key and we'll store it in O2 AA. So LDA, I've called it keyboard, haven't I? Keyboard. So now we load the keyboard, then compare it with 64. Branch if equal to read keys. There's the list of commands. Oh, there's the list of commands that are available to me. Yee. If you do exclamation mark list, you'll see the commands that are available to you. I'm an administrator. I've got lots more commands. Who did that? Ah, Stuart. Yeah, you're a mod, so you get more more commands than me. So it's my exclamation point, my AMK points to see your own, or you can say AMK top 10. That'll give you the thing. Right. I've got to figure out why my scroller's gone all funny. Right. So now we're reading the keyboard. If it's 64, we go back and read the keyboard again. If it's not, we're going to store it in key. Yeah, which is here. He's trying to break the bot, but I've fixed it. Right, so we'll test the first one, which is this here. Yeah, so we'll test for going up. So we've got key, so we're going to compare it with 10. And branch if not equal to so that's going up. Test key down. So that's where we're going to go next. If it is, then we're going to load Y, set the carry, subtract increment, and then store it back into Y. Andy's cheating. And if that's once that's done, then we're going to jump to modify sprite 0. So put a modify sprite 0 there. So that's done up. Now we're going to do down. So down we compared with 12. So we're going to compare with 12. Branch if not equal to test key. What's the next one? Left. Test key left. So test key left. And here we're going to load Y, clear the carry, add the increment, store it back into Y, jump to modify sprite. Right, key left. So compare with 47. Branch if not equal, test key right. So here we're going to load X low, set the carry, subtract the increment, store it back into X low, jump to modify sprite 0. And then here we're going to test for 44. And here we're going to say test for key fire. And here is, we're doing the opposite. LDA X low, CLC, ADC ash increment, store it in X low, jump to modify sprite, and then test fire. Well, compare it with what was we using? 20. Compare with 20. Branch if not equal to, and we'll go back to read keys. It should be within striking distance. If it's not, we'll change the way it is. And for fire, we're going to load. Did we have a colour? No. So what we're going to do, we're going to increase sprite 0's colour. And then modify sprite, is next, so we're going to tell it. So basically, load x low, store it in sprite x, LDA y, store it in sprite y. What else did we do? That's it. So we should be able to run this. This needs to go jump read keys. Right, we should be able to run this, and we should looks like we've got an error. Oh, it's just too far. It's just too oh no, hang on. Typo. Right. Well, it assembles. There's our sprite. Go! Go! Right. Our increment is way too big. Right. Let's let's put that down there. Right. F5. Right, here we go. Go! Oh, it's still wackily fast. Absolutely. Look, it's stupidly quick. It is ridiculously quick. Down, up, down, up, down. Yeah, so we're going to put the raster check in, alright? We're going to put the raster check in. It's just ridiculously fast, that is. Right, okay. So we're going to put a raster test in. So, LDA, look in the good book. Raster. It's got to be further on, that is. Sprites. Is it? Oh, it's DO12 in it. Yeah. Thank you. Yeah, we're not testing the most significant bit. Right, hopefully that should have slowed it down a little bit. It's still going to be quick. It's still going to be quick. Right, here we go. And we're off. Boop. There we go. So we can put the increment back to 5 now. F5. Go. There you go. Now the problem is we're not going to the edge. Sprite color didn't sprite pointer didn't update. No, because I haven't implemented that yet, mate. But the sprite color should be right. There we go. Right, so yeah, Gray sussed it out. Yeah. So now we're not going to the edge of the screen. We're not going to the edge of the screen, so we need to do something about that. Yeah? And the way to do it is we here, excuse me, here we branch if carry set and decrease X high. Bypass. So if we grab that and we can put it on this one as well, but this time it's not branch of carry set, it's branch of carry clear. And we can ink that. And so when we come to modify the sprite here, we can now do this. So we load sprite MSB and it with so we mask off everything 1 2 3 4 5 6 7 0, so that's 4 and 4. Yeah, mask it off and then OR it with X high and then store it back into MSB. Now someone's going to be shouting at me because this will only work for sprite 0. We're only working with sprite 0. Alright, if we was working with sprite 1 and sprite 2, then we'd put a 0 there, and this would be to the power 2 to the so this would be 2 to the power X high. Yeah, but we're not. We're just working with sprite 0. So now that should go all the way around the screen. So let's find out, shall we? Go away, go away, go away. Down, up, down. There you go. Now, to implement the direction change, easy peasy. Because all we're going to do is on the different tests, so here, going down, and going up and all that. So this is going up. So we are going to load #192 and store it in sprite pointer. And then going down was 193. Going right was left, sorry, was going left was 195, and this one was 194. So this now should make the sprite point in the direction we're going. So here we go. Down. There you go. And we still got the colour changing part of it. So, Brendan, this was all for you, seeing as you are a patron of mine and you asked for some help. Does this explain and show you how to get a sprite on the screen both using basic, both keyboard and joystick, and using assembly for the keyboard? So Stuart's just asked a question about doing fractions, increasing the sprite using fractions. Yeah. So we can do that. Yeah, I used it in Neptune Lander. Oh, thank you for the bits, WauloK. It's much appreciated. Oh, great tutorial. Thank you. I mean, do you want me to go into the fractions? How we can, instead of using increments of 5. So what it means is there, if we go drop it down to 1, yeah, and we F5 it, and then move. Yeah, that is slow. And what Stuart's wanting us to do is to make it go even slower. Yeah. So we can do that, and it's called using fractions. Yeah. Yeah, well then we can remove the raster check, yeah. So if you want me to go down the route of having to do binary fractions, we can do that. So the way a binary fraction works is that you have your, like in decimal, yeah, decimal, you have 10.1, yeah, so that's your whole number. Hang on a second, guys. Just bear with me a second. I've just got to go somewhere. Hello. Mrs. OSK apologises. She had a technical issue that had to be rectified. Right. Right, so decimal fractions, yep. So like in decimal fractions, you've got the whole number and you've got the fraction, yeah? Well, binary fractions are exactly the same. So binary, so we have same thing. We have the fraction and we have the whole number. And Minecraft crashed. Did Minecraft crash? Yes, they do. Well done, Gray. Right, so a binary fraction is exactly the same. The only difference is with a decimal fraction you go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, yeah, and it goes in tens. So you've got tenths, 100ths, 1000ths, and so on. With a binary fraction, it's a bit different because a binary fraction goes like it goes 1/2. 1/4, 1/8, 1/16, 1/32, 1/64, 1/128, and finally 1/256. In that order, yeah. So if you've got a 1 in your fraction and then 0, 0, 0, 0, 0, 0, so we'll do that. So if you've got in your binary fraction 1, 1, 2, 3, 1, 2, 3, 4, that is equal to 1/2. Alright? Yeah? If you have 0 on and that is equal to 1/4. And so it's working its way backwards. As the whole number works that way, so binary that way, binary fraction goes in the opposite direction. And so the way to implement your binary fraction, so let's say we want our increment to be quarters, yeah? So if we go to the increment, so instead of it being 1, if we do this now, 0, 1, 1, 2, 3, 4, 5, 6. So that's now our quarter. Can I please repeat the last bit of the binary fraction? It's a 1 256th. That's the last bit. So it's 1 over 2 to the power of whatever bit it is, yeah? Or should say 1 over, 2 to the power of whatever the bit is, yeah? So we're going to increment by quarters, yeah? Now the way to do that is we need to have some more variables. So we're going to do this. X frac equals $02A7. So we'll make that 8, 9. And then we're going to have Y frac, which is equal to O2A. Yep. B, C. So we've now introduced 2 more states of X and Y. So we've got the fraction state and the whole state. Yeah. So we need to we're going to need to initialize the fractions. Yeah. So LDA #0, store it in X frac. It's not picking it up. Frac. And store it in Y frac. So that's initializing our fractions. Because the reason why I'm initializing the fractions here is because we're initializing the whole numbers here. Alright? In fact, we can do that there because we're initializing the high byte as well. Alright? So instead of adding and subtracting to the increment, yeah, we add to our fraction. So we take the fraction and we apply the increment and we store it back in the fraction. So now, in terms of Y, we've got to now test for the crossover. So branch of carry set, which means that we didn't cross over at bypass. Yep. Then we do dec Y. So because we're subtracting a quarter from the fraction, as soon as we get to the point where it crosses over, we need to then decrease Y. So we'll do the same thing for increasing Y, for going up, which is this one. Right, so we'll put that in. And this is frac. And this is carry clear, and this is ink. Alright, so next thing is we need to, we'll try that out, yeah? So now we're moving even slower. So if I do F6, we've still got the raster check on, so we're going down. Even slower. That's because we're still doing increment. But can you see that it's jerking because we're now moving every fourth because of the fraction value? So what we need to do then is apply it to X. Now X is going to be a slightly bit different because I need to check something. Where's the instruction set? So if we're doing a decrement, what's set? Yeah, we can do that. We can do that. So, we'll do the same with X. So we've called it X frac, didn't we? Yeah, X frac. So, that's Y. Here's X. So, we're going to do X. So, we'll do the bypass here. So, plonk that in. And that can go there. Right, X frac. X frac. Decrease. X low. Problem is, now we need to, here, instead of branch if carry set, we need to do branch if not equal to. Because if that goes to 0, so goes to 0, then we need to decrease this. Yeah. And so we need to do the same thing. So that bypasses that way. Oh, this is going to cause a problem. Bypass 1. There we go. That should sort it. So we do the same on this side. So frac. Frac. Put that. So branch of carry clear. Inc. X low. Then branch if not equal to. That's not right. The voice in the back of my head's going mental. Right. Bypass to there because we're not doing that. Yeah, that's better. That's better. The voice in the back of my head's now happy with that. So branch if carry clear to bypass, which is not that one. So increase branch if not equal to 0 by bypass, and if it is equal to 0, do that. Right. Oh, pressed F6. Oh, there's an error anyway. Oh, invalid branch. Oh, it's gone. It's gone. It's busted the limit. Right, okay, so branch if equal to colour change, which is here, and then jump. Right. F5. So we'll see if my logic's right. So down, up, there you go, left and right. So as you can see, it's jumping now because we're now tied into the raster. But what I'm going to show you is here we're going to change the increment. So instead of it being a quarter, yeah, we're now going to make it, even slower, and we're going to go there. No, not there, there. So that's a 16th. Yeah. So we're going to take that. So it's going to be even slower. So here we go. There you go. It's even slower, look. Now, we can take the raster check out. Alright. We can take this out now because we're that slow, we don't need to do that now. So oh, I've pressed F6. Right, F5. There we go. So no raster check on, and that is on a 16th. That's increasing by a 16th on every cycle. Look how fast it is. It's ridiculous. So now we've taken the raster check out. Let's put the increment on the extreme. Yeah. So that's one. So every cycle is 1/256th of a pixel move. Right? Ready? Here we go. F5. So down. There you go. That's to move 1 pixel. It's cycling 255 times to do this, because we've taken the raster check out. So if we want to speed it up and double the speed, we can do that. So this should make it 2 times faster. There you go. Alright, so that is how you work in binary fractions. Alright, so we've taken out the raster check, which basically stops us until the rasters hit the bottom of the page, and then it does our bits for us. We've now stopped it. Yeah, sure. What's the matter? Yes. So we'll put that in. Right, so so we'll do the one you want, yeah. Whatever 190. Well, you just add it up, so it's 128 and 64, isn't it? 192 is that plus that, yeah. 88, yeah, that plus that. So it's going to actually be the binary representation of it is actually that. Yeah. So let's fire that up. Ready? So that's increasing. That means it's going to cycle around 192 times before it moves a pixel. Alright. So I hope you guys have, well, it was mainly aimed at Brandon. Brandon, are you now happy that you should be able to replicate this? I'll put this in the GitHub. Yeah, I'll put this in GitHub. In the Twitch stream ones. Hang on, let me get it up. So what I'll do is I'll put it into this one, the Twitch streams. So there'll be a new folder called 10. Yeah. So you can then download the code and try it out yourself. So if that, so this is my first patron question stream, because this stream was because one of my patrons asked how to get a sprite on the screen, and I decided to do it both in BASIC and in assembly, so you can understand the understand the mechanics in BASIC, and then you can apply those mechanics into assembly. So has that helped, Brandon? And have you got any other questions before we sign off? All right. I don't see anything in chat, so I presume everything's fine. All right, guys. Well, thanks for joining this this tutorial session on how to get sprites on the screen using BASIC and assembly. And I will then leave this with you, and I will see you on Monday with 3D Maze and see what we can get up to with 3D Maze. And I've got to figure out why my scroll banner's not working. Alright guys, well thank you very much for joining. I hope this has been informative and entertaining, and I'll see you later. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.